I want to share with you a visualization platform in JMP that I find myself using more and more. It's the Variability Chart, and it's especially useful when you are comparing groups or even groups within groups. Let me show you how to use it, and you can see whether it's something you can benefit from. If you want to follow along in today's session, all of the data that I'm using can be found in the sample data index. And let me show you where you can find that. So you go to Help, then you go to Sample Index, and something like this comes up. And we're going to start off by looking at the two-factor crossed. In the two-factor crossed dataset, we have 4 columns. We have measurement, operator, part, and standard. Where to find the variability chart is go to Analyze, Quality and Process, and then Variability, the attribute gauge chart. And the way it works is you put your response up here. So I'll put my measurement here, and then you put your grouping variables in the X. And now you could easily do something like this in the graph builder too, but I just find that it's super quick and easy to use when you do it like this. From scratch, it'll look like this. I think I always add is the connect cell means option, because it really quickly gives you an indication of how the different subgroups are moving within the other group. So in this particular case, we have 3 operators. We have Cindy, George, and Tom, and they have measured 10 parts. Now, because it's a crossed data set, that means that I'm able to, cross. What means that these parts can be measured by all the operators. So I can see whether the single part makes a difference. If this was a destructible test, as in my next example, we would not be able to have the same part being analyzed by multiple operators. So here we have just a visualization of the measurements, and we can quickly see that Cindy and Tom have the same structure in their measurement. So you can see it kind of have this weird shape, and Tom has the same weird shape, but George has something different. Now this is much easier to see if we add the R and R plots, mean plots, because then we get this. And then you can really quickly see whether they follow each other or they do not. So that's the first thing that can be helpful to add. The other thing I use the variability gauge chart for is to look for heterogeneity of variance test. The first thing I like to do is make them as wide as the other graph, because then they will align. And what this test does is to see whether we can go with the assumption that the variances are equal within the groups. And looking at the standard deviation chart, not going to be the case. So we can see, because they're outside the control limits on my standard deviation chart, I can't assume that they have equal variances. I can do that with within part, and I can also do that with the part times operator. So that's really, you can do so much more here, but this is just a great start. But let's go to example number 2, which is then the two-factor nested. And if we go to Analyze, Quality and Process, Variability Chart, and we go like this, I don't know if this is helpful, but if you mix these up the wrong way, it will come out not the way you want it to, which happens to me all the time. If that happens, you see here, it's especially bad because all the parts are unique. If that happens to you, go redo, relaunch, and make them in the right order. And I don't know if this is a helpful rule to remember it by, but the order you put it here will be the opposite of what you see it. You see, so before I had part and then operator, and then I have operator part. So now that I have operator part, I will get it as part operator. So it's kind of, just remember this, it's the opposite. It's a horrible rule, so I keep doing it wrong. But never mind. The connect cell means option here doesn't really make a lot of sense, because it's not the same part. So we can't assume that that part will have the same mean, but nevertheless, we can see, just looking at the standard deviation, that something's off. So again, we want to go and do the heterogeneity of variance test, which is now nested, and I'll make them as wide as this one. And if you hold down Control, you make them all at the same time. And again, we can then see, well, we can assume equal variances for most, but not for Robert. And Just looking at this, we can see why. Well, it's an assumption when I compare means that I have equal variances. Of course, there are tests that does not have that assumption. When we look at path, again, there are some paths that has much more variance than others. Again, what I use this tool for is quick overview. How is the data structured? Let's do a last example. Let's do the 3-factor nested and crossed, just to have both. So again, if we go to Analyze, Coordinate Process, Variability Chart, and we do all of these, and the Y, and okay, we get something that looks like this. So it's nested and then crossed. We have 4 different operators. Let's do the distribution plot this time. And I love the distribution platform because right away we see, okay, none of these are overlapping. So Maria is measuring 1 and 5, Ewan 2 and 6, and so on and so forth. But we are able to measure the same paths across. But for some reason, we cannot cross the instrument. Maybe they really like their own measurement equipment and they're not borrowing it to others. I showed you a few times that I like to connect cell means, and I like to do the gauge and out plot if I can, and I like to have the heterogeneity of variance test. If I know I want all those 3, I just, instead of clicking here 3 times and doing them one at a time, what we can do is just hold down Alt and click there, because that will then show us all the possible options underneath that red hotspot. And sometimes that's just much quicker. It can be easier to just read through, well, what do I have available? And I want to connect cell means, I want the gauge and out plot, and I want the mean plot, I want this one and that one, and I want the heterogeneity of variance test. And it's nested, then crossed. Holding down Control to change all of them at once, and we can see, well, it actually looks pretty good. We have, looking at the shapes of these, they seem to be similar. Well, maybe not all of them. So scrolling through here, see, are there any red dots? Well, no. So we can actually assume variances are equal across all of these sub-batches. So if we wanted to do an analysis of this gauge and out study, I like to do the variance components because it's easy to read through. If we look at it here, we can see that operator is 7% of the total variance. Instrument is 3%, path is 84, operator by path is 1, instrument by path is 2. So if we just should focus on one of these, maybe operator, but again, 84% of the noise is coming from path, which is the great thing because that's not on us. We are the measurement department. Noise due to path, that's the production, so it's their problem. Yeah, that's it for this video. I hope maybe you can see yourself using this platform. If you have any questions, don't hesitate to put them in the comments. And thanks for watching.